Hi there. Today we're going to talk about growth and decay application type problems. This is for exponential growth, exponential decay, and then we're also going to be doing compound interest. So our first formula is up here. This is exponential growth. This is y equals a times 1 plus r to the t. Now each of these different things means different things. So like the y value stands for your final amount. It's your ending amount. The A value is your initial amount. So in your problem, it'll say something like this starts as a certain number of dollars, or you start with a certain amount of a population. The R is your rate. You want to make sure that this one is going to be a decimal. So for instance, if it is 12% growth, you're going to move your decimal to the left 2 spots, and that would be 0.12 for your R. If you had something that was 0.3% growth, you would move your decimal over 2 spots, and so it would be 0.003 for your rate. And then the last one is your time. That's going to be your exponent. This is exponential growth because this 1 plus r, that would be your base, and since it's going to be greater than 1, your functions will be growing over time. So let's take a look at what this would look like in a word problem. So you have a radio station sponsoring a contest. You have a $100 gift card. However, if you don't make it within the first 15 minutes and it's wrong, you then the next day it's a rolling prize. The prize is going to increase by 2.5%. So this 2.5% here, this is going to be your rate. But once again, we're going to want to move that decimal over 2 spots. So it's going to be 0.025. You have a lot of other information here. This $100, that is going to be your initial amount. So that is going to be your A value. This 15 minutes is kind of an extra number that we don't actually need when writing our equation. It's just a time frame for the problem to occur. So looking at this, I'm going to zoom up so we can see our equation here. Write an equation to represent the amount of the gift card. Well, we don't know the amount yet, but we're looking for t days after there's been no winners. So we need our initial amount, which we determined is going to be the 100. Our growth is going to be 1 plus the rate. Now the rate here is 0.025 because we moved that decimal over 2 spots. In this one, we don't know the time yet. It just says use t for time. So this would be our equation. So we are now going to use that equation for part B. How much is the gift card worth if no one wins after 10 days? Well, see, now here we are told our time. So what we're going to do is we're going to first write our equation on all of those. I'd like to see your equation just to make sure that part's going okay. So time is 10 for this one. After we have our equation written, what we're going to do is we're going to go ahead and take out our calculator and just type all of this in at the same time. You don't need this graphing calculator. You can use just a normal calculator, and that's totally fine. What we're going to do, though, in either case is we're going to do 100 parentheses 1 plus 0.025, close your parentheses, and then we need to go to the exponent. So we're going to use the caret key to the 10th. If you're using a phone or one of the ones on the computer, it might actually be a little bit more challenging. So just please be very careful with your parentheses and your exponents here. When you hit enter, you should get 128.008, which in this case, we're talking about money. So we're going to round to 128.01. Okay, so for the next one, we have the same idea where this is going to be exponential growth. I can tell because this says the college's tuition has risen 5%. That means it's going to be a growth for exponential. We're starting at the year 2000. And in the year 2000, the initial cost is $10,850. That's going to be your A value. We're looking to write an equation for after t years, what that would be. So we're going to do y equals 10,850, parentheses 1 plus our rate. Since our rate is 5%, we're going to move the decimal over, and it's going to be 0.05. And so we want to write an equation for t years. That's the first part. Part 2 says predict the cost in 2025. So we have to be careful with year 2025. We want to know how far apart are 2025 and the initial year of 2000, how far those are apart. So what you can do with your dates here is you can go ahead and subtract the years. And so your time pace in this one is going to end up being 25 years. So we're going to do 10,850. 1 plus 0.05 to the 25. And when we type this one in, 10,850, 1 plus 0.05 to the 25th power, we end up with $36,741.95. So $36,741.95. So now what we're going to do is we're going to move on to exponential decay. Now here's the good news. Everything is exactly the same, but the only thing is in order to make it decay, it has to decrease, so your rate is going to be negative. So it's going to be 1 minus whatever that decimal should be. So let's take a look at what that means for this first example. So you have a raft. We can tell this is decay because it's losing 6.6% of its air. That tells us we're going to be talking about decay. The original raft could have 4,500 cubic unit inches of air. So that's going to be your A value. Your 6.6 is your rate, but we're going to move our decimal over, so it's 0.066. So we want to write an equation to represent the loss of air. So we don't know what we're ending with. We know we started with 4,500. We know this is decreasing, so it's 1 minus the rate, which is 0.066 to the t. And so now what we're going to do is we're going to take this equation and use this to find after 7 days the amount that we would have. So it's 4,500, 1 minus 0.066. 7 is our time, so it's our exponent. So we're going to type all of that in on our calculator. You just type it all in the same way. And we should end up with 2790.23 cubic inches of air. Let's take a look at another one with population. So we have this population that has been decreasing. So again, that's what tells us it's decay, because you see that word decreasing. The average rate is 0.3%. So this means our R value, once we move our decimal over 2 spots, it's going to be 0.003. In 2000, its initial population is 88,000. So then we are asked to write an equation to represent the population since 2000. So we're going to do y equals 88,647 times parentheses 1, and it's a decrease of 0.3%. So we're doing 1 minus, and we turned our 0.3% into 0.003. And years since 2000 is just going to be t. The next question, now we want to predict the population in 2020. So we're going to use 88,647, 1 minus 0.003. Since we are now in 2020, that is going to be a difference of 20 years. So again, you can always take your times and you can subtract them to figure out what your t value is. Now, I do want to show this one. So it's 88,647 times 1 minus 0.003 to the 20th. So we type all that in on our calculator and we get this decimal. So we get 83477.07. So now with this one, you have to be careful because we're talking about people. This is a population. So we're not going to have that decimal. Anytime it's talking about people, you're going to round just to the nearest person. So we're going to have 83,477 people in the year 2020. So there's one other type of formula, and it is actually called compound interest. So compound interest is you're going to put your money in a bank, and they're going to say, we're going to give you this interest rate, but we're going to compound it annually or quarterly or something. It'll say compounded and then a word after that. Our formula is very similar to the growth formula. So looking at this, you have a bunch of different values. You have your end amount. So A is your current amount or your end amount. P is your principal. That's your initial amount. So that's what you start with, just like your normal growth formula. Whatever you start with goes there. T is your time in years. So that's, again, not changing. Your rate here is going to be expressed as a decimal, so even the rate is similar for this one. So if it's like 6.2%, you would move that over and your rate would be 0.062. 0.062. So the only thing that is different is that you have this divided by n by your rate and your times n by your time. So n is going to be the number of times something is compounded each year. So you might see something that's compounded daily. So that would be 365 for n because days, there are 365 days in a year. If it says weekly, we're going to use 52 for your n value. If it says quarterly, you're going to use n equals 4. If it says monthly, you're going to use 12. So let's take a look at an example using the monthly. So we have $14,000 invested. That's your P value. 6% means your rate is 0.06. Compounded monthly. That's what tells us we're using this formula. There are 12 months in a year. We're going to figure out how much money, or first we want to write an equation to represent the amount of money in the bank. So it's 14,000 times 1 plus, here's where our formula gets a little different, it's 0.06 divided by your n value. So notice here I'm dividing by 12 to the n times t, which for this one again, your compounded, your 12 goes there. We want to figure out after 10 years how much we're going to end up having. So what we're going to do is we're going to do 12 times 10 up as your exponent. So visually, we have 14,000, 1 plus 0.06 divided by 12, close your parentheses, to the, and I would put parentheses around this depending on which calculator you're using. You want to do 12 times 10 up there. So you still can just type this all in at the same time and hit enter. When we do that, we got the $25,471.55. Let's do one more. We're investing this $300. That is going to be our P value or our initial amount. 3.5% means our rate is going to be 0.035. Compounded quarterly, again here, this is what's telling us it's this compound problem. Means it's quarterly, 4 times a year for 22 years. So we're going to do y equals our initial amount times 1 plus our rate divided by our n to the n times t. So we have 300, 1 plus 0.035 divided by 4 to the parentheses 4 times 22. So we get 645, 70, what was that, 76? Yeah, 76. So as you're reading the problem, just be careful if it's growth or decay or compound interest. And thank you very much for listening.